Let us see 19th problem of this miscellaneous exercise, chapter number 5. Using mathematical induction, prove that d by dx of x power n is equal to n into x power n minus 1 for all positive integers n. Here in 11th standard we have learned regarding mathematical induction. By using mathematical induction we have to do this one. In mathematical induction what we used to do is we used to take the given statement as p of n at first. So taking the given statement as p of n here, let p of n be the given statement. Then p of n becomes d by dx of x power n is equal to n into x power n minus 1 for all n belongs to z plus positive integers. And then what we used to do is we used to prove this statement for n equal to 1. At n is equal to 1, LHS of this statement is equal to d by dx of x power 1. d by dx of x is 1, and RHS of this statement is equal to 1 into x power 1 minus 1, which is equal to 1 into x power 0, whose value is 1. LHS equal to RHS. So P of 1 is true. P of 1 is true. Next one, after proving it for n equal to 1, we used to consider P of m is also true. So let us take that one. Let us consider P of m is true. So P of m becomes here, P of m becomes d by dx of x power m is equal to m into x power m minus 1 for all m belongs to z plus. Let us take this as 1. After considering P of n to be true, we used to show that P of m plus 1 is also true. P of m plus 1, here we shall write like this. Now we shall prove that P of n plus 1 is true. So d by dx of x power m plus 1 we can take here is equal to d by dx of x power m into x power 1. So this can be taken as uv form here, u into v dash plus v into u dash x into d by dx of x power m plus x power m into d by dx of x here, x power 1. So this can be taken as x into d by dx of x power m. d by dx of x power m from equation 1 it is m into x power m minus 1 plus x power m into d by dx of x is 1. So here we can write it as m into x power m plus x power m. So in the next page I will write this is equal to x power m common m plus 1 we can get, x power m common m plus 1 will be left here. So this can be written as m plus 1 into x power m plus 1 minus 1. See, d by dx of x power m plus 1 is equal to, we are getting it as m plus 1 into x power m plus 1 minus 1. Therefore p of m plus 1 is true. P of m plus 1 is true. Hence by the principle of mathematical induction, P of n is true for all n belongs to n. Let us see one more problem of this series. Let us see one more problem. Here, 18th question. F of x equal to mod x whole cube. Show that f double dash x exists for all real values of x and find it. F of x is mod x whole cube here. Show that f double dash of x exists for all real x and we have to find f double dash x. So first of all, f dash x can be found like this: 3 into mod x whole square into d by dx of mod x, and this can be written as 3 into mod x whole square into d by dx of mod x is x by mod x. So this can be taken as 3 into x into mod x, which is f dash x, and we shall check whether f dash x exists for all real values of x or not. So especially at x equal to 0, we shall check here. And this is for x not equal to 0. For x equal to 0, we have to check left hand differentiability of this function. L f dash of 0 at x equal to 0 is equal to limit h tends to 0 minus f of 0 plus h minus f of 0 divided by h here, and this can be written as f of see here, left hand differentiability, limit h tends to 0 minus f of 0 minus h minus f of 0 by minus h, which is equal to limit h tends to 0 minus and f of 0 minus h, f of minus h becomes minus h whole cube minus f of 0 is 0 here by minus h, which is equal to limit modulus of minus h is h here, so h cube by minus h cube by h, which is equal to limit h tends to 0 minus h square we have, and this is equal to limit h tends to 0 minus of minus h whole square, which is equal to, this value becomes 0 here, and right hand differentiability, which is equal to limit h tends to 0 plus f of 0 plus h minus f of 0 by plus h, which is equal to limit h tends to 0 plus f of h is h cube minus f of 0 0 divided by h here, whose value can be taken as limit h tends to 0 h cube by h, which is h square. We can get answer is 0 here. So therefore left hand differentiability of the function is equal to right hand differentiability of the function is equal to 0, which implies f dash 0 is equal to 0. So the function is differentiable at x equal to 0 and first derivative of the function exists. So we shall check for the second derivative, or else second derivative of the function, whether it is existing or not for all real values of x. So first of all, here f dash x is equal to, as we have seen earlier, here f dash x is equal to 3x mod x, 3x mod x for x not equal to 0, and this is equal to, this value will be 0 if x equal to 0. For x not equal to 0, f double dash of x is equal to d by dx of 3x mod x. Derivative of a function is double derivative. So here we can write like this, which is equal to 3 into d by dx of x mod x, uv form again, which is equal to 3 into x into mod x derivative, 3 into x into mod x derivative, d by dx of mod x is x by mod x, plus mod x into x derivative is 1. Like this we can write. So this is equal to 3 into x square by mod x, means mod x we can write mod x plus mod x. So this is equal to 3 into 2 mod x, which is equal to 6 mod x. 6 mod x we have. So first derivative of the function is existing for all real values, and second derivative we found like this for x not equal to 0. For x not equal to 0, we have to check at x equal to 0 whether this function is existing or not. For that one we shall find the differentiability of the function, left hand differentiability of this function and right hand differentiability of the function. Left hand differentiability of this function can be taken as limit h tends to 0 minus f dash of 0 minus h minus f dash 0 by minus h, we can write simpler way. So if you simplify this one, you can get like a limit h tends to 0 minus 3h into mod h minus 0 divided by h, and this can be equal to 0 somewhat, you will get as an answer. And right hand differentiability of this function double dash of 0 is equal to limit h tends to 0 plus f dash of 0 plus h minus f dash of 0 by h, This value, if you simplify and if you find, you can get it like limit h tends to 0 plus 3h mod h minus 0 divided by h, you can get, whose value can be it can be like this value is equal to 0 here also in this case. Therefore this implies f double dash of 0 is equal to 0 here, and thus we find that f double dash of x is equal to 6 mod x for x not equal to 0, and this is equal to 0 for x is equal to 0, and this will exist here, second derivative for all real x. Or we can write still like this: f double dash of x is equal to, or else 6 mod x for all x belongs to R. In this way we can do this problem. This is an important problem of this exercise. Dear children, try the next problems, whatever left in the miscellaneous exercise, by yourself, as they are somewhat easier level. Let us discuss some other topic in the coming videos. Thank you for watching, and keep on practice maths.